Hi there, welcome back to the channel, and today I will show you how to measure distance using the HC-SR04 ultrasonic rangefinder. Here it is. So as you can see, it's got 4 pins, so I'll just do a brief description of what the roles of those pins are. So we have VCC is the voltage, and ground there to complete the circuit for the power. And then we have 2 pins of interest here in the middle. We got trig there, and we have echo in this way. So what trig does is that it sends a pulse in the form of ultrasonic sound. So, you know, like say X was this sound, it would be greater than 20 kilohertz, which is beyond the audible range for humans. And echo is the receiver of that ultrasonic sound, essentially. So if I draw it here, what that would look like. So here we have a bird's eye view. And then, for example, we could have this wave going out like this, and there's a wall, and then that wave would bounce back and be received by the echo pin. But how can we use this to measure distance? So let me get rid of this. So what we have here is we need to use the speed of sound. You can Google this to find the value. You will see it. It's 343 meters per second. But for the case of this video, I will convert this to centimeters per microsecond, and I'll just quickly do a walkthrough of how we do that. Okay, so we take 343 meters per second, then we multiply that by 10 to the 2, 10 to the power of 2, because centimeter is 10 to the minus 2 meters. So we want to do this essentially the other way around. And then divide the bottom by 10 to the minus 6 to get microseconds. Then we should end up with a value of 0.0343. I've run out of space, so I'll write the units here. Centimeters per microsecond. Okay. That's the basic math there that we will use to calculate the distance. So now let's get into the programming, and I'll show you how it's done. Okay, so let's start by calling the classes from the libraries. From machine we can import pin and I2C because we want to display these distance readings on an OLED display. From time, we're going to import sleep for any delays that we require. From SSD1306, we're going to import SSD1306_I2C because that's the connection protocol we use. And then import UTime, microtime. U just means, the letter U is just the kind of letter abbreviation for micro. So let's start by defining the pins for the OLED display and the the ultrasonic rangefinder. So trig will be equal to, we're going to connect it to GP15, and in the MicroPython define that as an output. Then echo will be connected to GP14 and define that as an input. Then we're going to do this I2C variable, and here we will call the I2C class function peripheral 1, SCL is equal to pin 19, SDA equal to pin 18, and frequency of 400 kilohertz to be precise. Then OLED variable equal to SSD1306_I2C. Then we define the horizontal pixels, the vertical pixels, and call the I2C variable like that.
So now everything is ready to go. Let's do the modular programming style again. And let's start with the ultrasonic rangefinder. So we're going to initialize that trigger signal as low, do a delay for 2 microseconds, for example, trig.high, sleep for another 5 microseconds, and trig.low. Okay, so now that's the trigger signal set up, so it will be only on for about 5 microseconds, I believe. And now let's turn our attention to the echo pin. We're interested in that value. So while there is a 0 value on the echo pin, we're going to tally that time that the signal that the echo value is equal to 0. We're going to call that time off equals to microtime dot ticks underscore microsecond. So that will tally the off time in microseconds, and we're going to tally the on time now in microseconds in the same way. So time on will be equal to utime dot ticks underscore microsecond. And then to calculate the time difference, essentially, is time on minus time off. And now we can finally calculate the distance. So distance will be equal to, we're going to round it to 1 decimal place here, time passed in microseconds times by 0.0343. If you remember, the unit for this variable here, this number, is centimeters per microsecond, and this time passed is in microsecond. So microsecond will cancel out, which will leave us with centimeters, which is the distance. But that's the distance of the time it takes for the trigger signal to hit that object and come back. So we divide that by 2 because we're only interested in the first half of that distance, essentially. Then we round that to 1 decimal place, like so, and then we return that distance value. So we can pass it on into the OLED display function, like this. We're going to start by defining the OLED.fill0 to refresh the display. Then OLED.text. We're going to make a nice entrance here for the distance variable. Put that into a string, distance variable. And then, to be nice and follow good practice, we will put the unit there, centimeters. And then last thing to do here is just define where in X and Y terms are we going to place this text. So we're going to place it on the left hand side, of course, so we have a lot of space, and then halfway through the screen. Then OLED.show to display this text, and then sleep for 0.1 seconds. And then the last thing to do here is to do the infinite loop, where we can call these functions. So distance will be equal to the ultrasonic function, and then we pass that distance value into update OLED, like this, and then sleep for 0.1 seconds. Okay, so here is all of the code that is required to make this work. So let's start by building the circuit.
Okay, so this is ready to go pretty much. I've done everything apart from insert this HC-SR04 sensor. So if you want to see how I connected the OLED display, you can watch my last video where I interfaced the OLED display with the readings of a temperature and humidity sensor. And now I just want to explain these wires to you. This is where I'm going to connect the distance, the ultrasonic rangefinder. So the blue wire here is the VCC wire, and I've connected that to 5 volts. So if you power your Pico with a micro USB cable, it's going to be a 5 volt signal here on the VBus pin, which is physically the 40th pin, the top pin on this side. The orange signal is the echo pin, the black wire is the trigger pin, and the yellow wire is the ground pin. So all that stuff for me to do now is to insert the sensor like that and run the code. There we go. So as you can see it there. As I move my hand backwards and forwards, you can see that I get a new reading on the distance display. Just like that. So obviously I can't put my hand right up against that. We're going to get some errors in the readings. And that's just normal because of how this sensor works. So within a certain range, a sensible range, this sensor will work just fine. So as you can see, as I move my hand one more time, the distance changes appropriately with the distance of my hand. Okay, so that's all I have for today's video on measuring distance with the ultrasonic rangefinder. I hope you learned something new. Thank you very much for watching.